It happened! Elon Musk just revealed this amazing new powerful nuclear reactor. Welcome to Techno Universe. We are here yet again with another fantastic video. Let's get started, shall we? Elon Musk has publicly revealed his nuclear power plants. The concept of nuclear power and how it may be used to generate electricity, fuel, and energy is that it is both extremely dangerous and heavy. Elon Musk, on the other hand, is developing a portable nuclear power plant that can be carried with you. We've never seen anything like it. A low-cost, lightweight energy producer that generates more electricity for less money. Former SpaceX engineers have created the world's first portable zero-emissions power source. It is a mobile nuclear reactor that can be easily erected in cities and provide power to remote areas. You might be curious to learn more about this and Elon Musk's work on nuclear reactors, as well as how this breakthrough may bring us one step closer to conquering Mars. You don't want to miss anything vital, so keep watching until the end of this video. If you haven't already, please subscribe and enable notifications. Let's get this party started, shall we? Nuclear energy is a key topic at SpaceX, Elon Musk's space company, and there are still plans to colonize Mars, which will necessitate a transportable source of energy, which is now being developed. Furthermore, contrary to popular belief, Elon Musk believes that present nuclear power plants are safe. According to him, nuclear power can be developed to be exceedingly, incredibly safe, and that it will be based on fission rather than fusion, as we would have envisioned in the beginning. It is the process used in conventional nuclear reactors, and it is characterized by the collision of two neutrons with the same larger atom, splitting it into two and releasing energy in a process known as nuclear fission, also known as nuclear fusion. Furthermore, the fusion reaction is the inverse of the fission reaction, in which smaller atoms collide and fuse to form a larger atom, releasing energy in the process. The process by which the sun generates energy is known as solar fusion. Some argue that fusion is a safer process for generating nuclear energy than fission because fission generates radioactive waste that can endure a long time, whereas fusion does not generate long-lived radioactive waste, among other reasons. However, current technology creates a hurdle for nuclear fusion since it needs all of the energy it generates to continue its reaction, leaving no net energy available for use by other devices. Despite the fact that multiple companies are attempting to commercialize fusion energy, none has proved successful. Elon Musk, on the other hand, has long advocated for the use of nuclear power. Elon Musk, the CEO of SpaceX, did not explain in his lecture on how nuclear power facilities may be made extremely safe. Former SpaceX engineers are working on the world's first portable zero-emissions power source, which will be able to provide electricity to remote locations while also allowing for the installation of new units in congested areas. Radiance technology, which is currently in development, will enable nuclear reactors to be transported in an entirely new way. As micro-reactors, which are relatively lightweight and cost-effective, become more widely available, nuclear power is becoming more portable. The Tokamak Reactor. Fatima Ibrahimi, a physicist at the Princeton Plasma Physics Laboratory (PPL) of DO, recently announced a new proposal for a new propulsion system capable of delivering a spaceship to Mars rapidly. It is astonishing that the journey will only take 3 months. In fact, Princeton has a reactor, the work of which encouraged Fatima Ibrahimi to consider a nuclear rocket engine, the effectiveness of which makes a voyage to Mars a feasible possibility. We're referring to the Tokamak Reactor, a toroidal vacuum chamber with magnetic coils that uses a magnetic field to contain and regulate the high-temperature plasma inside the reactor. The plasma on the sun is restricted by enormous magnetic fields in the same way. The Tokamak reactor resembles a donut and is practically hollow on the inside. If you bought it at Dunkin' Donuts, you'll be disappointed as the plasma fills. The particles are accelerated to 20,000 meters per second in a cycle inside the reactor, and the plasma forms a closed cord. When the torus is opened and the energy is released, you get the terrific thrust and, more crucially, excellent braking. Because reaching insane speeds is only half the battle. It is also critical to brake at the appropriate time. According to Fatima Ibrahimi, a spaceship powered by such an engine will arrive on Mars in 3 months. When compared to previous performance with chemical rocket engines, this is insignificant. But how does it apply to rockets? The tokamak's peculiarity is due to the fact that the larger the donut, the more stable it is. The concept of a tokamak was first proposed by Soviet physicist Oleg Lavrentiev in the mid-1950s. At the time, the United States, the Soviet Union, China, Japan, and South Korea were all actively developing this technology. Depending on the strength of the magnetic field, the plasma in the system either slows down or accelerates. The density of the plasma is determined by the magnetic field strength. In the Sun, similar occurrences can be witnessed. Plasma in tokamaks can theoretically be heated to 150 million degrees. In comparison, the hottest portion of the Sun has a core temperature of approximately 15 million degrees. The problem is that it is unstable, and the smaller the tokamak, the more pronounced the unstable behavior of the plasma. When plasma comes into contact with a reactor wall, it instantly loses energy and destroys the reactor walls. In 2016, the world record for high-temperature plasma was set on board the South Korean K-Star Tokamak. The plasma was heated to 50 million degrees and kept in a magnetic field for more than 70 seconds by the scientists. When the plasma came into contact with the tokamak's wall, it lost its shape and converted into steam. Reaction came to a halt. As you can see, even in the terrestrial laboratory, technology is still imperfect. How does this work in a flying object? The nuclear rocket engine is relatively small in size. It's unclear how nuclear physicists might regulate the plasma in such a reactor. If the engine fails, the astronaut situation will be less dire. So far, Princeton scientists have discovered a way to prevent the tokamak walls from collapsing. Boron, it turns out, handles this far better than other coatings. There is also a more efficient and safer method of covering the chamber walls with boron that does not need stopping the tokamak. Boron powder is fed directly into the reactor during operation. The technology, according to test leader Robert Lunsford of the U.S. Department of Energy's Princeton Plasma Physics Laboratory, is more effective and less harmful. Assume tokamak can be rescued from destruction and restarted in space if necessary. How are we going to attain plasma stability? There is a belief that plasma acts more stable in a vacuum if the thermonuclear rocket engine is only functioning in outer space, allowing the wall to be removed from the construction and only small protective pads on the magnetic coils to remain. This would make it easier to ignite the thermonuclear plasma. When Fatima Ibrahimi saw the tokamak in her laboratory, she might have thought about this. If this is the case, we may soon see the engine envisioned by futurists aboard UFOs. As a result, the spacecraft's power plant must include a variety of rocket engines. A traditional chemical engine, for example, would launch a rocket into space, and work on a nuclear facility in space will commence. There is also the issue of selecting an appropriate working medium and nuclear fuel. Several requirements must be met in this case. The primary characteristics are compactness and energy efficiency. A spacecraft traveling to Mars would need to carry a lot of valuable technology, and such a nuclear rocket engine would provide a little utility if all payload capacity was consumed on fuel supply. Perhaps this is where Elon Musk's fanciful interplanetary transportation system will come in handy. Greetings and thank you for watching this video. Make sure to give this video a thumbs up and subscribe to the channel for more fascinating content.